Hello everybody, once again Mr. Fritz here to help you out with another compound inequality. This time we're going to talk about an OR compound inequality, and we have two separate inequalities that are separated here. So what we're going to do is we can solve each of these individually. We're not going to have to do kind of an all-at-once type of deal like we did for that and one if you watched the video before. So what I'm going to do is I'm going to split this down the middle here, and I'm going to take care of this left-hand inequality first. So the first thing that I'm going to want to do is distribute this 2/3. I'm going to follow my rules of algebra here, and I'm going to get out a 4/3 x minus, it's going to be 18/3 is greater than 10. Now this 18/3 reduces to 6, so that's nice. So I'm going to keep my 4/3 x minus 6 is greater than 10. Next step will be to add 6 to both sides. So this 6 will go away, and I'm going to come out with a 4/3 x is greater than 16. Now to get rid of this fraction, remember this is a fraction multiplied by x, and normally when we say that you're multiplying by something we want to divide, but when we're talking about fractions, the easiest way to get rid of a fraction is to multiply by the reciprocal. So we're going to multiply this by a 3/4. And whatever you do to one side, you have to do to the other side. So I'm going to multiply the right side by a 3/4, and this is like a 16/1. So these will cancel, will go away, they'll become 1. And I'm going to get out an x is greater than, and now actually what's convenient here is I can cancel out this 4 goes into 4 once, and this 16 goes into 4 times, so I'm going to reduce that before even multiplying through, and I'm going to get a 4 times 3, which is 12. So that's where this, that's where this inequality is going to stop, my left-hand inequality. So let's go back to the top and now take care of our right-hand inequality here. Same type of deal, we're going to use rules of algebra to get x by itself. I'm going to distribute that -3 first. So let's do that. And we're going to get a -3x. And now watch your signs here. A -3 times a -1 is going to give me a +3, which is greater than 12. Next step, I'm going to subtract 3 from both sides. This goes away. I'm going to come out with -3x is greater than 9. And now I'm going to have to divide out that -3 from both sides. So I'm going to come out with an x, and now remember the sign is going to flip here because I divided by a negative number. So x is going to be less than -3, and that one was a lot quicker than the left-hand side one. So I've got my two inequalities. I've got x is greater than 12 and x is less than -3. So I'm going to plot both of these on my number line here, and then I'm going to graph the final solution set together. So let me write the first one here. X is less than -3, and then let's go with purple for the second one. X is greater than 12. So my first number line here, let's see, we'll put -3 here, and I want x is less than 3. Now this is just less than, not less than or equal to, so I'm going to have an open circle, and my numbers less than -3 will be going to the left on the number line. So there's my arrow pointing to the left, or depending on how you're looking at it, this way. Now I'm going to plot this inequality next. X is greater than 12, so let's put 12 over here on the number line, and again open circle because it's greater than, and I'm going to point this time to the right. My final solution set now, and when I'm graphing this, remember this is an OR inequality. So if I'm dragging my pen across the number lines here for both of these simple inequalities to find my solution set for the compound inequalities, I'm going to look for wherever my finger crosses any line. Any line. Doesn't have to be both because this is an OR. So remember, OR, either. Either or, either or, both and, both and. So I have a line here with an open circle, and I have a line here with an open circle. So to find my final solution set, I'm just going to combine both of those simple inequalities. So my final solution set will be x is less than -3 or x is greater than 12. That's it. You can think of this as I'm thinking of a number, and that number is either less than 3 or greater than 12. Well, that's going to be all of these numbers here. So that fits the OR compound inequality. And that's how you do that one.